So I'm going to be making 3 diagrams based off of the data that we've been using. So we're going to be looking at a histogram, a frequency, polygon, a stem and leaf plot, and a box and whisker plot. Now this all follows the data from the previous information we used, where we had students who are taking their history essay and the times that the students took them in. Now, we made this big table where we talked about frequency, cumulative frequency, relative cumulative frequency. For our histogram, we're going to make a frequency histogram. The instructions say to label the y-axis with frequency. So that means that we only need frequency. So you can see I copied that table over here. Now what we do need to do is organize the data into intervals. Now remember that a histogram is like a bar graph, except the x-axis has numbers, has numerical data, and the bars touch each other. So what are we actually going to put on the x-axis? If you think about it, from 12 to 59, that has a range of 47. So I could make my intervals, 2, but that would make for a really boring graph. Look, a lot of these frequencies are 1s or 2s. So we would just have a very long graph with a bunch of short bars. So when that happens, we want to have fewer intervals that are wider. So the first thing we want to do to find the intervals is we want to find the range. And the range again is going to be, here, let me actually show you my calculations there. It's 59 minus 12. It's the largest value minus the smallest value. And so that is 47. Now I'm going to divide this by what's called my bins. So how many bins am I going to have? Where am I going to throw this data? Generally for a histogram, rule of thumb is 5 to 20. Now for my class right now, we're not looking at this very much in depth. So if you choose any number in that interval, it's fine. Now again, if I broke this up into 20 intervals, it would not be very informative. It would look horrible. So again, fewer intervals would be good. Now, looking at this number, 47, that's about 48. I mean, it's pretty close. Now, if you remember, 48 is 6 times 8. If I divide this 47 by 6, I'm going to get about 8. I actually get like 7 point whatever. But if I say, all right, I'm going to make 6 bins, and that means that the width is going to be 8. So each interval is going to be covering a distance of 8 values that I can dump these into. So what I want to do is to actually break this up into little groups. So if the width is going to be 8, my starting value is 12, then if I have a distance of 8, it's going to go up to 19. Now I know what you're thinking. 12 plus 7 is 19, but we count 12. So if you count 12, 13, 14, 15, 16, 17, 18, 19, that actually has 8 values in there. So that's covering 8 distance, or distance of 8, width of 8. So then the next interval is going to be 20 to 27, then 28 to 35, 36 to 40, 43, 44 to 51, and 52 to 59. Nice intervals there. Now this set of data is actually really nice because these are all integer values. And with these integer values, we don't have to get really complicated with this. Now, what's going to happen is, remember, after 19 comes immediately 20. So in this set of numbers, in this set of data here, 19.5, 19.6, they do not exist. So our interval is going to stop at 19. The next one's going to start at 20. They're actually going to border each other. So we're not going to have a gap between 19 and 20 because in this set of only integers, 19 and 20 are next to each other. They're infinitesimally close. And you'll see what I mean when we actually plot these points. So between 12 and 19, how many do I have? Well, here for 12, I have 2 values. 20 to 27, that only includes 20, which is 4. 28 to 35, that includes 28, 30, 32, 33. And so that's going to be 1 plus 1, which is 2, plus 2, plus 1, that's going to be 5. 36 to 43, that includes 38, 39, 40, and 42. So that's 2, 4, 6, 7. 44 to 51, that includes 44 and 48 to get a distance of, frequency of 2. And then 52 to 59 is going to be 2, 4, and 5. So these are my frequencies. So now what I have to do is just make that graph. So I start by making my y-axis and then my x-axis. What I'm going to do here is I'm going to start at 12, and I'm going to put this little symbol. This just means, hey, from 0 to 12, we're just kind of skipping over that because there's nothing there. For this graph, it doesn't make a huge difference, but imagine that our data starts at 200. We're not going to graph everything from 0 to 200 and just show nothingness. So this saves us some time. And so I'm actually going to go up by 8s, where I start, or all these values are the beginning of my frequencies. And then going up, and actually 60. And going up, I'm going to have my frequencies. So 1, 2, 3, 4, 5, 6, and 7. I have to make sure I label this, so I'm going to put this as frequency. And the x-axis, don't forget this is time, which is going to be measured in minutes. Okay, so I'm going to make my little bars. And so I'm going to make a line color around these just so we can see how they're different. All right, so the first one is from 12 to 19. So I'm going to go up to 2. And I'm going to extend this over to 20. And this shows that the frequency between this range, or in this interval, has a frequency of 2. So anything from 12 up to 20, but not including 20, has a frequency of 2. Next, starting at 20, and then going up to 28, but not including 28, I have a frequency of 4. Next, starting at 28 and going up to including 35, it's going to be a frequency of 5. Next, between 36 and 44 is going to be a frequency of 7. Between 44 and 52 is going to be a frequency of 2. And then finally, between 52 and 59 inclusive, so up to 60, has a frequency of 5. Now, because I made this by hand, or kind of by hand using a computer, it's not going to be perfect, but this gives a pretty good idea of what this histogram would look like. And you can see that this actually does a really good job of representing the data. We can see that there's this large group at the end that doesn't sort of fit the rest of the data. And if I were to have you guess where's the median or where's the mean, you'd probably say somewhere in this range between 36 and 44, because it looks like there's a fair amount of data to the left and to the right, and this is where there's a large group of them. So that's why we would do it. And everything worked out nicely here. So again, first thing, and the hardest part actually, is to determine your bins and how wide they're going to be. So I saw that 47 is close to 48, which is 6 times 8. So I said, all right, well, why not make 6 bins? And you can see I have my 6 bins or bars, 1, 2, 3, 4, 5, 6. And if I divide 47 by 6, I get about 8. I'm rounding because I'm dealing with integer values, so I should probably make this with an integer value as well. And that makes it a width of 8. And so by making my intervals, I group the frequencies into these intervals, make my histogram, and I'm done. Now, for the frequency polygon, it's actually very, very similar. So much so that I actually use the same data. And I use the same bins, the same frequencies. Now, I can't say I've actually seen a whole lot of frequency polygons around, but they still do exist. They're still important. So again, on the y-axis, I'm going to label my frequencies. Now the setup is the same, and I'm actually going to do the same bins, the same calculations. So rather than doing that from start, I am going to just use my setup from the previous problem. And so on the y-axis, I have the frequency again, 1 through 7. Now here for these intervals, I'm going to use them. However, what I'm actually going to do is I'm not going to do those intervals themselves. I'm going to do the midpoints. So refer back to this histogram here. From 12 to 20, the midpoint would be halfway between there, so that would be 16. So I'm actually going to start this at 16 and again make my little mark saying I'm skipping over 0 to 16. Now the next interval, 20 to 28, has a midpoint of 24. Next interval, 28 to 36, has a midpoint of 32. 36 to 44 has a midpoint at 40. 44 to 52 has a midpoint of 48. And 52 to 60 has a midpoint of 56. So instead of drawing bars and all this, I'm just going to draw points. So at 16, this interval here, 16 represents that midpoint. What's the frequency? Well, for that interval, frequency is 2. So I draw a point there. 24 is the midpoint of 20 to 27. So that frequency is 4. 32 is the midpoint of 28 to 35. Frequency is 5. 40 is the midpoint of 36 to 43. That frequency is 7. And 48 is the frequency of 44 to 51, so that's 2. And 56 is the final midpoint with a frequency of 5. So just like I would with scatter plot or whatever, I'm actually going to connect these dots. And so I'm going to do this. Connect all these dots with straight lines. And imagine that, again, I drew these down to the x-axis. Look at that. I would have a polygon. I don't actually draw that down to the x-axis. I'm just saying that just to show you how we get the name frequency polygon. And that's it. So again, the setup's the same for the histogram. Find those bins, find those widths. But instead of saying, it covers this range, I'm just going to use the midpoints, finding the median of these groups. Okay, next up is stem and leaf plot. Now, stem and leaf plot is actually very nice, very simple, and surprisingly meaningful. It's used very commonly, and it gives us a lot of good use. So I'm actually going to cheat and use some sort of a text box here. And what this is going to do is it's going to let me make stems and leaves. So what I do is I make stems going down, and on the left-hand side of this stem and leaf plot, they're going to be my stems. So I do stem of 1, 2, 3, 4, and 5. Yeah, that should be okay. Let me just extend this tree, if you will. And so these stems represent the tens. So notice with this set of data here, I have 12, 12, 20, 20, 20, 20, 28, 30, 32, etc. What I can do is I can say, I'm going to group everything that is in the tens together. So those two 12s, I'm going to say this is 10 and two ones, 10 and two ones. And I read this as 12 and 12. For the 20s, I say, all right, well, that's two 10s and 0 ones, 0 ones, 0 ones, 0 ones, 8 ones. Now you can see I have 20, 20, 20, 20, 28, just as is in the data up above. For the 30s, it's 30, 32, 32, 33, 38, 38, and 39. For the 40s, I got a 40, a 40, 42, 42, 44, 48. So I do 4 and 0, 0, 2, 2, 4, and 8. And finally, for the 50s, I have 52, 52, 54, 54, and 59. So counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That's my set of 25 values. And notice when I count it, I only counted these ones because these over here, again, they just represent the first part of that number. Now, what I actually would need to do to finalize this is make a key. And so the key is just going to show you how you read this. So for example here, I'm going to say that 1 line 2, that equals 12. And by me saying this, it shows what this is. For example, sometimes this line, this could mean a decimal point. And so this 1 line 2 would equal 1.2. Drastically different. So without the key, we actually can't read this stem and leaf plot. But with it, it's nice because if you think about the histogram, oh, I can see there are a lot of values between 36 and 44. Great, what are those values? You don't know. You can't tell just from the histogram alone. Are all these values 36? Are they equally spread out? Are they all at 40? There's no way to tell. But here, if we want to see between 36 and 44, we can see, oh yeah, there's 38, 38, 39, two 40s, two 42s, 144. Kind of a nice little spread there. So that's why stem and leaf plots are nice and effective. Now moving into box and whisker plots, again, we want to find some information. So we could actually use a stem and leaf diagram for this, or we could use the original string of numbers. For us right now, I'm going to use the original string of numbers, but we could do the same thing with a stem and leaf plot since it gives us that. All right, so what we need to find out is the lower extreme and the upper extreme. Those are just the, actually I'm going to use a highlighter. Lower extreme and the upper extreme, those are just the smallest number and the largest number. So the lower extreme is going to be 12 and the upper extreme is going to be 59. The median, remember that's the middle number. So if we have 25 numbers here, the median is going to have 12 to the left, 12 to the right. It'll be the 13th number. So if I count in 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This number here, 38, represents my median. So that median is 38. Now what's this business of first quartile and third quartile? Well, what we're actually doing is we're breaking this data up into fourths, quartiles, 25%, 50%, 75%, 100%. So imagine I have a line and I want to cut this into fourths. Rather than just saying, eyeballing it up and saying, oh, that's about fourths, a more effective way is actually to cut it in half and then to cut those halves into half. And those look pretty good, actually. So what I'm going to do is I cut this set of numbers into half. Now I'm going to look at those respective halves and cut them into half. So this bottom set of numbers, this bottom half, has 12 numbers in it. So the median would have 6 to the left, 6 to the right. 1, 2, 3, 4, 5, 6. Remember, with an even set of numbers, the median is actually the mean of these two middle numbers. So between 20 and 28, the mean between those two is 24. So we actually call that median of the bottom half the lower quartile, or the first quartile. The upper quartile, we do the exact same thing. There are 12 numbers up here. So 1, 2, 3, 4, 5, 6, 6. Yep. So between 44 and 48 is going to be our median of this upper half. So 46 is that number, and that is the upper quartile, the third quartile. Now do note, the median is not included in either of these sets. If we have an even number, we would include, like, say, I want to break these up. I would not include this 24, but the 20 would be in this lower half, and the 28 would be in this upper half. Okay, so actually now I'm ready to make this box and whisker plot. And so what I'm going to do first is I'm going to draw an x-axis. Now the box and whisker plot actually has one dimension, even though it actually looks like it has two. I'm going to start by making my intervals. Now it doesn't really matter what we count by. I'm going to count by 5s just because I have a range that goes from 12 to about 60. So I'm going to start at 0 for this one. Don't have to, but well, I can. So sometimes when I have a large spread, a large range of numbers, doing intervals of 5 is actually really nice. Okay, so actually what I'm going to do is I'm going to look at the lower extreme, which is 12, so that's about there. And well above this x-axis, actually none of my bar graph is going to, box and whisker plot, none of this is actually going to touch the x-axis. So I plot this point at 12. The upper extreme is at 59. So those get 2 dots. Actually, it doesn't really matter. Some people do lines, some people do little x's. It really does not matter. So just mark those 2. But what does matter is that the quartiles and the median, they get straight lines. And so at the lower quartile, or first quartile, is 24. So at that point, I'm going to have a nice vertical line. At the median, I'm going to have another vertical line. The median is 38, so 38 is about there. And at 46, I have the upper quartile. What I'm going to do is I'm going to connect these tops and bottoms. Try to make this look a little bit nicer. This is not the ideal software to be making a box and whisker plot. Actually, it doesn't look too bad. And then that's the box. So the whiskers are from connecting these two extremes to pretty much the midpoint of these boxes. And that's our box and whisker plot. Really straightforward, really simple. Now, why do we make a box and whisker plot? Each of these segments is a quartile. It's a quarter. So it represents 25% of the data. So you can see that this middle 50% of the data, actually more of that is just above the median than is below the median. So box and whisker plot can be really telling. All right, so those are just 4 types of diagrams. really the 4 types we will be focusing on in my class. So that's a box and whisker plot, stem and leaf plot, frequency polygon, and the histogram. So make sure you review these so you feel comfortable with them, and let me know if you have any questions.